Okay, so let's start from where we stopped yesterday. Yesterday we have seen the checks from number 1 to number 3, and now we will continue with number 4, which is to check the presence of the spot color inside the PDF, which is pretty easy. So to do this, we run again our PDF Toolbox application, and from the Tools menu we select Profiles. Inside here, we can build our profile that contains just one check, because in this case we want only to check the presence of a spot color. The check is done this way. Is a combination of two colors. The first two checks, sorry. The first one is checking if the object is defined using a spot color or not. In this case, we want to catch a spot color, so we have set that to true. And the second one is that we want to avoid to catch the registration color, to do not have any false alarm. So it's pretty easy. I already have included this check into my profile. In this case, there is nothing else than this. So let's get a PDF that contains a spot color. In this case is this top right orange area, but we can check with our color picker to make sure that yes, this is defined, you see, with a spot color named orange. So running this profile against this PDF, we expect that the system will report this. So I drag and drop the PDF on top of PDF Toolbox, and then we are ready to run. I click on the button Analyze and Fix, and the system, you see, is reporting us the presence of a spot color as an error. The same thing we have seen yesterday, we can do today. It means we can generate a PDF report and save to the desktop, so that this way we have the possibility to visualize where our spot color is located. You see that in our PDF we have this patch, this image, which has a transparent red area on top of that. This is to highlight where the spot color is used, and also we have some annotation that are giving us additional information. You see that mousing over, the system is telling us where the issue is and which the issue is. There are two, because in the PDF these are two images. So we have the girl, which is one image. The second one is the grid with the colored patches. These in the PDF are two different objects, so the system reported two hits. This is the reason, and for the same reason it has highlighted with two different annotation. Okay, so this is pretty banal, but what is useful here is that with this kind of reporting, we make visible where the problematic areas in the PDFs are, and this will make easier, of course, for us to fix. In this case, with the PDF with spot could be okay, but in the case we want to avoid, then we know which is the image that we have to convert to CMYK or RGB before processing. So let's go with the next step, which is more interesting, because this is more structured. The issue here is that we could have the case where the graphic placed the PDF in the PDF the text too close to the bleed area, like in this case. This is something that usually we want to avoid, because we need to have a safe area close to the bleed where we don't want to have any object. This to avoid to have any problem when we cut the material, and also because it looks not so great. But the technical reason is the first one. It could be problematic to have a precise cut when the object is very close to the margin. So what we want to have here is a fix-up that in this case will alert us for any object that is placed in a PDF too close to the bleed area. To do this, we can do a check that is combining two different things. In PDF Toolbox, we have a nice predefined checks that is alerting us in the case that we have a distance from Trimbox, which is the rule we define here, in this case less than, and in this case we have entered as a limit safe space a quarter of inch. As we have seen yesterday, this is a text field, so we can enter whatever we want. We can change to half of an inch or to any other size, and we also have the possibility to define the dimension in inches, in millimeters, centimeters, and so on. Then another relevant thing here is that we can define the measurement from Trimbox, so it could be from inside or from the outside or both sides. In this case, selecting both, the check will be triggered independently if the object is inside or outside the bleed. We don't want, in this case, to have anything close to the bleed box, independently if it is inside the trim box or outside, so that in the bleed area. Then we can define the scope. In this case, we want that the check will be applied for all the pages in the document, and then the scope. We can also select the direction. So in this case, checking against the top, the left side, the bottom side, or the right side. Practically, this means, let me reopen the PDF. In this case, it will check along all the border of this object. So it means from the top, left, bottom, and right side. So the text could be placed also closer to the left, right, or also bottom margin. And defining the check with this scope will make sure that all these cases will be catched. Another check that we need in this case, that we have to combine to this checking distance, is that we wanted to check in this case only text objects. So not images, because it could happen that we have a nice background imaging that will go outside the trim area, and most probably will cover also the bleed. And we don't want to have any errors in this case, because that is wanted. But for the text, this usually is not wanted. It could happen that we have a PDF, you know, that where the graphics sometimes place some text, like in this case you see the big white number in the background. In this case, this is an image, so it's not a text. It is an image, but it could happen that the graphic do the PDF using a font instead to have an image. In this case, the system will trigger because the font, in this case, the text is closer to the margin. This will not happen again because this is an image, but to exclude that all other objects except the text will trigger the check, we have to include in the check definition also this additional check. So the combination of the two will trigger. That practically means whatever is a text in the PDF and small and closer to the trim box area with a distance which is less than whatever we have defined here will trigger this check. So let's see how this will work. Let me cancel this and this. So we take our PDF with that text close to the margin, and we run our pre-flight profile. You see that the system is giving us an error. It has, of course, identified the presence of this text close to the bleed area. Again, in this case, it's very easy to identify because we just have one element, but you can imagine for more complex PDF that it would be interesting to have, again, a visualization of the problematic areas. In this case, you see the system highlighted with the red stroke, the text, which has the problem. And again, if you mouse over that, the system is reporting the reason of the error. In this case, it's easy because we just have one object and we just have only one check in the profile. But you can imagine what can happen when we have multiple checks inside this list. For example, the presence of a spot color or RGB colors or missing font or distance to the bleed box, like in this case. You know that in that case it's not so trivial to identify where the problematic area are. So having this kind of visualization of the problematic areas will make it much easier to first identify where the problem is, and second, to also understand which the problem is, and so also which is the solution. In this case it's banal because to solve this we have or to remove this block of text if not wanted, or just to move away from the border. Okay, so this more or less complete the section regarding the checks. So I would move to the fix-ups, which is the most interesting part, because the main difference is that now with fix-ups, we not only identify the problems, but we are also trying to fixing them. This is not always possible, of course. For example, if we are missing a font, then we cannot build a fix-up that all the time will fix this. If in the machine where we run PDF Toolbox we have the same font, then the system can fix this, but if that font is not present, that we can do nothing. So in that case the system will just report an error, but it will be not able to fix that. So let's start to see the first typical problem. This is one of the most common issues that we have to address, which is the bleed management. The bleed, in this case, the request is to make a fix-up that is doing different things. The first thing that this fix-up has to do is to check if the bleed in the PDF is present or not. We can have two cases, of course. One is that the PDF has the bleed, and the other one is that the PDF is without the bleed. So this is the first step, but this is not enough, because we want also to make sure that in the case the bleed is not present, we want to add a bleed to the PDF with a size that is 1/8 of inch. And also in the case that the bleed is present but is not the wanted dimension, then we want to fix this too. That means that we will have in this case to first remove the presence bleed, and then we have to add the bleed again at the wanted dimension. So we have several things to do, which is a mix of checks, fix-ups, and also adding some logic, because we needed to add some condition. So let's see how we can do this. If I open my PDF Toolbox list, you see that the icon for this new object is different, is yellow, where all the other are blue. The difference is that since now we have seen profiles. So a profiles is basically a container of just simple checks and fix-ups, and whatever we include in our list, like in this case, will be applied. So we have one fix-up in this case, we can add more of course, and the same for the checks. So we can have a long list of objects. It doesn't matter if checks or fix-ups, and whatever contained here will be executed by PDF Toolbox, because they are all inside the same profile. But we have a limitation doing this. We don't have any possibility to add any logic. So to add the logic, PDF Toolbox make available another object, which is not called a profile, but is called a process plan. A process plan is a more structured object that can contain profiles, one, but also more than one, but also can contain single checks and also single fix-up. You see that when I click here on the object type, the system is adding on this list the object I selected. In this case, I have added two profiles, one check and one fix-up. And the system will process this list from top to the bottom, So starting from this first profile, then processing the second one, and so on. But you see that we also have the possibility to define some logic, because in the case we have an error running this profile, we can decide what to do, so that we can stop the sequence, like in this case, but we can also jump to a different step. So in this case, I have selected to continue with step 3 in the case there is an error in these profiles. So basically what happens is this. The system will run this process plan, starting from the profile we have at the step number 1. And in the case one of the checks inside this first profile is giving us an error, it doesn't matter which, just one, we have decided to skip to the step number 2 and to jump directly to number 3. So you see that in this case we have the possibility to apply some conditional logic. So depending on the results of the execution of one object, we can decide to define a different route inside the process plan. So in this case we just jumped to 3, so we skipped one profile, but we can also jump to the last one, for example, and in this case we will skip the number 2 and number 3. So now you see that using this different container is providing us a more powerful tool, because we not only have the possibility to fix and check a PDF, but we have also the possibility to define groups of checks and also to define conditionally which one of these groups we want to execute depending on the results of the previous steps. So the list can be pretty complex because we have no limitation. We can add as many steps as we need. And also in regarding to the jumps, we also have any limitation. So we can have several jumps, and depending on the result of each step, we can jump to another one. For example, we can jump from the step 1 to the number 3 in the case of an error, which is this one, which is just a simple check. In the case of an additional hit, we can just exit the sequence, and so this way we will skip the number 4. So let's see a practical example on this, which will make more clear how this new object works. So in this case, you see that I have defined a process plan to manage that bleed fixing issue, which contains 3 different things. The first one is a check, because the first thing we have to do is to check if our PDF has or not the bleed. To do this, I just made a simple check. You can click on the last icon, which is this blue pencil, and this will open the Visual Editor, where we can see how our checks is defined. In this case, you see I have combined together 4 different checks, which are basically checking the bleed size along the all 4 borders, so top, bottom, left, right. And for all the bleeds, I want that the system will make sure that the size of the bleed, if present, is exactly what we want to have. In this case is 1/8 of inch. So what happens running this check is that if the PDF has no bleed, or if the bleed is different to this size, the system will trigger an error. So let's see what happens in the case we have a hit. In the case we have a hit, it means the PDF has no bleed or has a wrong sized bleed, so we will continue with next step. In the case we will not have an hit, this will mean that the bleed will be correct. But if the bleed is already correct, then we have to do nothing else. So in that case, we will stop the sequence, and the system will do nothing else, because the PDF is already correct. So let's see what happens in the case we will not have the bleed, or the bleed is not properly sized. In this case, you see we have set to continue to next step, which is a profile at step number 2, and this profile is just removing the bleed. To remove the bleed, we basically have to do two things. The first one is removing the bleed. Removing the bleed, we have any specific command or any specific fix-up into PDF Toolbox. So we have built a workaround. The workaround is simply to redimension the page boxes. We can see here what happens. We are defining the art box, the bleed box, the media box, and the crop box, so all these four except the trim box, to the size of the trim box itself. This way we are shrinking everything to the trim box size, but doing this is also removing the bleed box, because the bleed box is the difference between the bleed box page and the trim box page. So is this area around the live area. But if we will resize all the pages to the trim box, you see that we are removing the bleed. So doing this with this specific fix-up, we are making sure that we have removed the bleed. This is not enough because we want to make sure that we will have any objects outside the bleed box. Sometimes in the PDF we have external elements like a slug line, or it could be a control strip with a colored patch or the crop box or something like that. We want to remove them in one shot. To do this, we have a specific fix-up which is exactly removing objects outside a predefined page area, which we have defined here below from this drop-down list, and we want to remove any object that is completely outside the trim box. When we have done this, we have made sure that our PDF has any more the bleed. And so this is the right time to finally add the bleed at the wanted size. To do this, we have a powerful tool which is generating the bleed from the page content. In this case, we have select as a method the mirroring edge. So basically the system is taking the content of the live area of the PDF and is mirroring it at the wanted dimension. In this case is again 1/8 of inch along the whole document, so the four borders. Since the system is rasterizing the contents, we have to enter also the resolution. In this case, we have defined to be at 300 dpi using a CMYK space color, or the output input of the PDF is if defined. It means the color space. If our document is defined in RGB, the system will use RGB. If it is defined in CMYK, then the system will use that space color, but if our PDF is missing the output intent, then the system will use the CMYK as a default space color. So after this long story, let's see finally how this process plan is working. So let's start from a PDF, which is this one. This is a PDF we have used also yesterday. It's a letter size, landscape mode, but this PDF has no bleed at all. So in this case, running this process plan, the resulting PDF should have the bleed. So let's run it. In this case, the system is asking me where I want to save the modified version of the PDF. So I select a different destination to not overwrite my original. And you see that the dimension of the document changed from 11.8.5. Now you see that we have a 1/4 of inch vertically and horizontally. This because the system added that 1/8 of inch bleed around the PDF. So to make sure the system did exactly what we wanted, we open the PDF in Acrobat and we can check with the page box tool which is our bleed box. Yeah, you see that the system applied correctly 1/8 of inch around my document. So this is the reason why it has extended the media box to make room for the bleed. It of course hasn't touched the live area, it just added mirroring the contents. You see along the left side, you see that the contents has been mirrored. Generally, there are two main techniques to add bleed. The first one is this one, is just mirroring the contents. This is working in almost all the cases, but we have another strategy, which is just enlarging the page boxes. So is the same technique we have used to remove the bleed, which was this one. We can define the same strategy, but in this case we can extend in the page boxes. So in this case we are enlarging the document and we are adding a bleed box. The main difference is that using this second technique we'll add a white bleed because there is no contents to duplicate or to mirror. The current case, what we have used now, is using the content of the documents, just mirroring it. So the bleed is something that cannot be 100% automated. This because it's very complex, there is no general rule. There are some PDFs where adding white background is more than okay, but there are other cases where this technique is not good, so that we need to use the mirroring. But also the mirroring has some issues. In the case the contents has some diagonal elements, because in this case the mirroring is not working pretty well. So the issue with the bleed is that in any case we need to have a visual check. This is a generic rule, it's not depending on PDF Toolbox, it's just because there is nothing that can automate this totally, making sure that it always works perfectly. So we can say that this is working in almost all the cases, but it is a good practice to always check before printing that the applied bleed is exactly what we want to have. Okay, so is more or less clear what we have done with the process plan. The major change is just that we added this new kind of container where we can combine together multiple profiles, multiple checks in a logical sequence executed top-down by the system, with also the possibility, you see, to add some kind of logic. This is giving us, of course, more possibility because inside one single profile we can have a different behavior depending on some properties of the documents. So for example, in some case we can define a check that is checking the presence of a spot color, and then we can decide, depending on which spot color it has identified, to make some specific conversion or to skip that. But the possibilities are really unlimited with this. We have some profiles that contains 30 steps with several jumps depending on the document size, depending on the presence on the bleed, and several others. And all this, the beautiful thing, is that when you export it, and you can do this in the same way for process plan and also for profile, you have this menu button on top right of the window, and inside here you have the possibility to export. But if you export a process plan or a PDF, the resulting will be just one file with the same extension. So from the outside, making a process plan or a standard profile is exactly the same thing. And the same thing will be when you will upload this file to tFLOW. It's just one file, and it doesn't matter if it is a process plan or a normal profile, because tFLOW is able to recognize internally which of the two type is, and there is nothing else to take care. It is all automated. So, and the same for importing, of course. So if I export this, let me do on my desktop, here. Okay, you see that the system created just this file, and if I wanted to use this in my tFLOW, I simply have to take this file and to upload in my automation scripts area. So basically, let me show you. We have my tFLOW instance. I go to my automation scripts. I click on add new, and I just have to drag and drop this. If I wanted to set this as a production profile, then I just have to save, that's all. The system now, you see, has included my new profile. In this case is just fixing the bleed, and now I am able to define one product or to assign that profile to an existing one, and I can select that fix bleed problems profile here in the production automation script. And now if I define a new product, entering the name, every time I will select this product in tFLOW, then the system will use this profile because we have assigned that profile to the production profiles. So in this case, I have to select here my product this way. And now the system is ready and will use my profile. And the same will happen if we will create a profile to make the proof, but also for the finishing. This is the reason why the system is asking us the type of profile when we upload something. This is because for each type, proof, finishing, and production, we will have a standard preflight profiles made by Callas. So the system cannot recognize internally to which destination this profile has to go. It cannot recognize if this is specific for production or for the proof or for the finishing. For this reason, we have entered these checkboxes where we can tell the system that the profile we are uploading, like in this case, is specific for production, for finishing, or for the proof. So let's see for finishing. In this case, I just renamed to make sure it's possible to upload. If I press save, in this case, the system will include in its automation script this profile, and it has associated this profile as finishing profiles. So in this case, it means that when I define a product, let's take again that my product we have defined, which is this one, I have the possibility to find that finishing profile in the list of the finishing automation scripts. Okay. In this case, the profile is the same. I just renamed, which is something we should avoid, but it was just to show you the logic behind tFLOW on how assigning the preflight profiles we have made with PDF Toolbox to the finishing or proof or production scripts. So let's see the next case. The last three cases are pretty simple. The first one, the number 7, is just to convert in colors. This is very powerful, but is also pretty easy to be defined because to do this, we have a ready-to-use preflight profile, which is called convert colors. In this case, what we have to define is the destination space colors. This is a ICC profile color. We have set to Greco 2006, which is pretty common in the US. And then other two things we have to take care is these assumed profiles. This because in a PDF we can have several objects, and each object can have its own specific color, space color definition. So we can have some images which are RGB, some other CMYK key, and we can also have spot colors and so on. Each object can have assigned a specific color profile, and this will make possible to apply the conversion. But it can happen that one or more object is missing the color profile, and this will block the workflow because in this case the system can't convert the colors because it doesn't know which is the source color profile. So in this case, to make the system working, we have to make some assumptions. So in this case, we have selected Adobe RGB and again the Greco 2006 to be associated for all those RGB and CMYK objects which are missing that ICC color profile. If they already have tagged, then the system will use that, but if they are missing, then the system is assuming these two, which of course can be changed. That's it. Then we have some conversion settings, but by default out of the box these are working pretty well. It basically is defining which kind of object we have to convert. In this case we are converting everything, including the spot colors, which is the last one. One thing that usually is changed is just the last one, depending if we want or not to convert the spot color to CMYK or not. If we want, then we have to use as is, like in this case. If we don't want to convert the spot color to CMYK, then we just have to remove this, save, and we have a profile that is preserving the spot colors. So let's see how this is working. It's pretty easy. Open again my test PDF because we know we have a spot color defined in orange, but we also have some other different space color. We can check using the object inspector and moving and clicking over the PDF. It will tell us which space color that object is using. In this case, this red-green colored box is defined using RGB color. You can see it here. It is using a color profile, which is a ECI RGB version 1.0. And we also have the spot color we have seen here. And then we have also other color definition, like in this case LAB, which is another way to define the color. In any case, what we want to have as a result is that everything in this PDF will be converted to CMYK, like for these images which are already defined in CMYK. So let's run this profile with this PDF and let's see what happens. So cancel here, upload the PDF, and now run the profile. I save on a different location again. You see that the system converted 86 objects. So let's open the result in PDF and let's see with the color picker that all the colors have been converted. So open the output preview again, and with the color picker we go to inspect the object. You see that in this case the object is now device CMYK, and also here is no more RGB, is CMYK as well, this as well. So everything inside the PDF is no more RGB or anything else than CMYK. We can click more or less everywhere to make sure it worked, but it seems it is okay. So you see that this is the typical color conversion profile. This is nothing that is changing so often, so that means that once we have defined it, is something we can usually forget. The only variance, which is what I mentioned, is the case where we want to preserve spot colors or not. To do this, a typical way is to create two different color conversion profiles, naming one like this one that is converting everything to CMYK. The other one will be converting only RGB to CMYK but not the spot colors. So the results in that case will be that we will have everything converted to CMYK but the spot color. One or more, it depends on how many are in the PDF. Okay. So next one, this is another very interesting case and also another very common situation. You know that the color objects usually are converted to rich black or there are, especially in digital printing situation, where we have a PDF that contains rich black objects, but we want to have them defined in a black only channel. We will see this second case because it's more complicated to be managed, but it is possible to be fixed automatically by PDF Toolbox. In this case, we want to have that all the objects that are defined with a color which is black 100 and combine the CMI percentage greater or equal than 30% are converted to black only. It means that if we have, let me open a text file like this one, if we have a PDF that contains some text and the color of the text is defined like in this way, in this case, which is 30% cyan, 30% magenta, 30% yellow, and 100 black, we want that the system converts automatically the colors to black only. So to do this, we have a couple of specific fix-ups which we have combined together. The first one is this map color. This is extremely powerful functionality for all the cases where we have to map or remap any color. It doesn't matter if the color is defined in CMYK, RGB, or it is a spot color, and also the destination. Using the combination of a source color model and destination color model, we have a very, very powerful way to apply internal conversion. For example, we can remap the name of the spot color in the case we have some wrong naming, or we can remap from a CMYK value, like in this case, to something different, or we can also do the same in the case the space color is RGB and also gray. So using this combination of setting fields, we have an extremely powerful object that allows us to remap our colors in several different ways. In our case, the source color, of course, is CMYK percentage. So defining this way, you see that we have defined a tolerance of 100%. We are picking up whatever is defined in CMYK inside the PDF independently from the percentage. So it basically means all the objects that are defined in CMYK, because the tolerance is set 100%. So this means practically a range from 0 to 100 for the all 4 channels. It means all the colors CMYK. We selected all here, which seems illogically, but we have combined this together, this check, which is where everything magically happens. Let's see how this is filtering the objects. Basically, this is filtering all the objects that are using the black with a percentage of 100. In this case, we have also a tolerance of 1, but it could be 0, so that it means all the objects that have the black channel set to 100, combined together this second check, which is basically filtering all the objects that are using CMI with the combined percentage that is greater than or equal to 30%. So combining this together is filtering exactly what we want. It means all the colors that have a K channel set to 100 and the percentage of CMI colors that are greater or equal than 30%. So basically this check is filtering all the objects where we will remap the color. For all these filtered objects, we want that the destination color will be 0 cyan, 0 magenta, 0 yellow, and 100 black channel. In this case, the range is 0, 1, so 1 means 100%. We could also define selecting the percentage here and entering 100. It's exactly the same thing. So let's see how this practically is working. So again, this PDF you see as the text defined with 100, 30, 30, 30. So let's run this pre-flight profile against our text PDF. So let's run it, save on a temporary location. Okay, the system has completed the work, so let's open the resulting PDF and pick up the color of our text to make sure that the system converted that rich black color to only black. So from print production, we select output preview, and with separation, we go over the black text, and now you see that the CMI colors are set to 0. So this means that the fix-up worked, so it has selected all the text because that was defined with the CMI combination greater or equal than 30% and black channel was 100. And for all this, the system converted to black only. Of course, we can do also the opposite, which is another typical situation where the PDF can have the black channel defined this way, so only black equal to 100, but we want to make in this case that black as a rich black. The procedure is more or less the same, but in that case we have to invert the mapping color, because in that case we need to invert the source with the destination this way. So in our fix-up, we need to invert, in this case, the tolerance will be 0. We will filter whatever is defined in 100 black only, and here we have to enter whatever our rich black is, which usually could be, for example, 40, 40, 40, 100. We don't need this anymore. We can tell all vector and text object because we want to select all, or we can do a specific check to filter which specific objects we want to have converted to rich black. This is doing more or less the same thing but in the inverted direction. So in this case, whatever is defined with black only color will be converted to rich black. So you see that more or less with the same fix-up, just with a different setting, we can do both the conversion from rich to black only and from black only to rich black. And also we can apply this fix-up to specific objects, to all the objects inside the document, depending on what we have defined here. Because this is just to apply the fix-up, in this case the map color, only to the object defined by the check we select here. Okay. So let's see the last case, which is pretty easy to be defined, is almost nothing to set here, but is another very powerful tool we have, PDF Toolbox, and it is really useful. The issue, let me reopen my Excel sheet, which is here. Okay, basically we wanted to flatten the transparencies. Let me open a sample PDF so we will see what the transparencies is. So in this case, we have our PDF, which is this nice brochure or whatever it is, and you see that inside the design we have this kind of bubbles or circles. But if we enlarge the document, we see that the bubbles or circles are overlapped. So like in this case, we have some transparencies because we have a background which is a picture, this yellow background, and then we have two circles overlapped, one on top of each other, and all these two objects are transparent. So for render this kind of PDF, the calculation in terms of resulting colors is extremely complex. And this sometimes is resulting in unwanted behavior in printing, even if all the most recent RIPs are able to manage properly. But in any case, for unflattened PDFs, the time for ripping is longer, of course, because the calculation is really much more complex. complicated because the system has to take in account the background color, the color of this object, the color of the second object, and also the alpha channel. So it means the transparency is set in the designer application, Illustrator or InDesign, and calculate the resulting color. And this for all the objects we have in our document, which could be several. And not only, but in this case we have 2, but the object overlapped could be 3, 4, 7, or 25. The more we have, of course, the more complicated the calculation is. And also the resulting color could be different from what we expect or what we see into Acrobat, for example, when we are inspecting the document. To see where the transparencies are, we can use also the output preview of Adobe Acrobat Pro. With the Object Inspector, we can select an overlapped area, like in this case. You see that we have different transparency group, one on top of each other, and each one has a specific alpha channel. The alpha channel is exactly the transparencies we have set in the application that we used to create the document. In this case, we have 2 different transparencies color. In this case are much more. You see how many are. And that means that to calculate the resulting color is an extremely slow and complicated procedure. And sometimes also the resulting color is not exactly precise or what we want. To avoid all this kind of issue, one good practice is just to flatten the document. It means to remove all these transparent objects and to calculate directly the color of the final resulting object. To do this, which is one of the most complicated things that we can do with the PDF in terms of mathematical calculation, we are lucky because we have a specific fix-up. This specific fix-up is a predefined fix-up we have in PDF Toolbox. Basically, it asks us for a few parameters, but out of the box. So it means by default, whatever you are seeing here, which basically is asking us for resolution and other more complicated settings. It is working very well, so there is nothing to touch here. So we can just pick up from the list of our predefined and use as is. All these other are to manage special cases which are pretty not so common, so we usually do not need to touch them. What is interesting is to see how it works. So I upload my PDF again on top of PDF Toolbox and run my preferred profile that is flattening my PDF. This is usually a pretty slow procedure. You see that with a simple document it has taken a few seconds, but for some complex documents where the calculations are huge, then it can take a few minutes to do this. The reason is that is one of the most complicated things that we can address in the with the PDF technology. But the results is that if I click of an overlapped area, you see I do not have anymore any transparencies. So it means, for example, that let me enlarge a bit. Okay. If I pick up, for example, this object, this kind of shape, which is resulting by an overlap of 2 different circles, this is no more in the PDF structure the resulting of different transparent objects, one on top of each other. The system just added a new object, is a new shape with its own color. That's it. So for any rendering and ripping system to process this file is pretty banal because there is nothing else to calculate anymore. Not only, but we have also the possibility this way to make a visual analysis of the resulting PDF to make sure that everything is okay. If I have this kind of evaluation and this gives green light to me, it means that if I send this to the printing machine, my result will be exactly like this one, like what is rendered. Having a lot of transparencies sometimes can result in unexpected behavior when printing. And the reason again is because of the flattening or missing flattening or the presence of the transparencies. One thing that is important to mention here is in the case we have, for example, two different objects which are set as transparent, and one is defined with RGB color or spot color, and the other one on top of that is in a different space color like CMYK key. In this case, sometimes, not all the times, it depending on the sequence, we have this color applied. The flattening is working well, but if we apply the color conversion profile we have seen previously, then this could result in unexpected colors. And the reason is exactly because converting colors when we have transparencies and these transparencies are involving RGB and CMYK color at the same time, then the color conversion is not working well. So a good practice in this case is to first convert all the colors to CMYK, and the last step is to flatten the document. So in this case, we have a PDF which is defined with the CMYK only color. But in the case one of these circles was defined with RGB and others in CMYK, the best practice is first to convert everything to CMYK and then run just after the conversion to CMYK the flattening process. If we flatten something that is using RGB and CMYK at the same time with transparencies, the results can be not so precise. So this is one of the little secret, but you don't have to take care because we can make a process plan that to do this for you. Okay. Do you have any question? Is more or less all clear? I know there are several things inside all this fix-up we have seen. Not so easy to have all clear at the first shot, but at least the logic I think is important, at least to have provided you a vision about what is possible to be done. This is just a short list of the potential of this tool. We can do much more than this. Okay. For example, what we have done here with this process plan, which I can send you later if you want, I combine it together whatever we have seen as a single steps for this training inside one single process plan. So all the steps we have seen plus much more, I have made just one process plan that including everything. It means that I can export just this process plan and all the flattening, the color conversion, the bleed management, and whatever we have seen will be applied in just one run. Of course, the resulting process plan is a bit more complex because it contains different steps, and also it contains a pre-flight profiles that it is contain several things. It is still missing one thing which we skipped yesterday, which is this one, document integrity. This is pretty banal, but I want to show you because it is very important. In PDF Toolbox, we have under the document section here inside each profile the possibility to set as an error in the case the PDF document we have uploaded is encrypted, or if the document is damaged and needs to be repaired. Of course, the reason is that if we have a damaged PDF, of course, the system cannot process. Like in this case, if I try to open this PDF, the system, in this case Acrobat, tells me that the document is damaged and cannot be opened. This in Acrobat is not a big issue because we just have to click OK, but if we upload this inside a web application like tFLOW, is much better to stop the workflow and to avoid that this PDF, which cannot be fixed nor previewed in any way and also not printed, will go through our flow. And to do this, we have just those two specific checks under the document section, which are these two that prevent that any damaged or encrypted PDF will pass along our flow in tFLOW. The difference is that damaged is something that has to do with the file structure itself, for example, a transmission error or whatever related to this. The encrypted document is a PDF where the user has set a certain level of protection using a password. In this case, the PDF is possible to be viewed but not changed. This means practically that we can apply the checks because all the checks are not altering the PDF, but we cannot apply the fix-ups because the fix-ups are altering the PDFs. But if the document is marked as read-only and password protected, then tFLOW is not able to apply any fix-up, and this is resulting in an error. So for this reason, we have to stop also the processing of the protected or encrypted documents. So this is something that we usually include by default in all the documents. Okay. So if you have still few minutes, I want to show you just one last thing, which is less technical, but just to give you an overview how the proof profile is working. You know that in tFLOW we have the possibility to upload also the proof automation script. This means that for any job we are uploading, let me open this one, we will have the proof created using a template, like in this case. You see that the artwork has been placed inside this nice framework where we have a top area with our logo, which can be customized, of course, using your logo. And we also have on the left column some fields that contains some information about the jobs we have created in tFLOW. In this case, we have ship date, order number, client name, and so on. The description here. And then we have also disclaimer on the bottom side and some other useful information. So whatever you see here can be customized, and we can provide you a customized proof template. What we will do is just to make a profile like this one, which internally contains a check that is checking if the document you have uploaded is portrait or landscape mode. And depending on the result of this check, what we have seen reviewing the process plan is applying a different template sheet with this frame around the artwork. And not only, but this is also making a low resolution version of the proof. This because the proof is sent by email by tFLOW, and in the case the PDF, the original artwork is a very large file, like several hundred of megabytes. Of course, we can't send that size by email, so we have to make sure that the final size of the proof is something around a few megabytes. So to do this, we have made a specific pre-flight profiles that is making a low resolution version of the PDF, taking out whatever is unwanted, and also converting to 100 ppi the artwork. This usually is pretty enough to make the final size of the proof document around a few megabytes, and this can be easily sent by email. So in the case you wanted to have a customized proof, I will show you what we will need. So let me take just a moment here, the imposition, impose, okay, manage imposition config. Okay, basically what we have to do is to create this kind of scripting. This is pretty complex, is basically for the imposition, so it's defining some rules where we have to place the object over the template, but what we need is just an empty template like this one usually made in InDesign with letter size, both portrait and landscape mode, so that we have our template which we can use to build your custom proof. So in your case could be more or less the same with your logo on top, and then for the fields here below, whatever you want. We have a predefined list of values. Of course, we can list here on the bottom whatever is included in tFLOW. So in this case, the ship date, we have the order number and the description, which are all properties of the job. So you see we have the ship date here, we have the description here, but we could also use the creation date, the job name, the notes, and whatever we have in the additional properties like all these fields. So, and also the quantity. The spot colors is something special, so is something we provide by the code inside the profile. So they are not listed here, but they are listed if any spot color is present, of course, inside here. We are managing this by the code. And other thing that can be defined is the colors of the fields. You see we decided to have orange text for our proof template and also the font. So everything more or less is customizable. We can provide you, in the case you wanted to have your custom proof template, our InDesign proof template basically are a couple of InDesign files that contains exactly this artwork. So whatever we have seen here, like in this case, for both the orientation. So we can provide you the InDesign file of this document and this document so that you have a good starting point to customize and make your own custom proof. Okay. All the rest of the work, it means to build the profile, exactly this one, which is a pretty complex procedure. We can do that for you. Because it takes into account different things, so it's not something very easy, but we can do that for you. What we need is just to have the template from you. So basically we can provide the InDesign file, you can edit, export again the InDesign work, provide us, and from that we can build the profile, the PDF for the template, like in this case, and then do all the rest of the work building the profile.